Hello, my name is Katia Chavez and I work for the Natural and Social Science Lab at the Miami-Dade College, Kendall campus. Today we're going to learn something about organic chemistry. We're going to learn how to write structural formulas from condensed formulas, okay? So the first thing that you need to remember are three basic but very important rules. These are called the golden rules. Rule number 1, carbon must always have 4 bonds. Rule number 2, an oxygen atom must always have 2 bonds. And rule number 3, a hydrogen atom must have 1 bond. So let's take a look at one example. You have to learn these 3 rules by heart and apply them in any problem that you encounter. So let's take a look at our example here. In our example, we are given the condensed formula CH3, CH2, CH2, CO, CH2, OH. So the first thing that I need to do is recognize the carbon atoms, and that's what I'm going to do, and I'm going to count them. So I see one carbon atom here, another carbon atom here, another one here, here, and here. How many carbon atoms do I have? I have 1, 2, 3, 4, 5. So that's what I'm going to draw. The second step would be then drawing those 5 carbons in a chain. 1, 2, 3, 4, and 5. What would be my step number 2? Well, this has to be related to the golden rule that I've learned, right? I must complete 4 bonds for each carbon atom that I have here. And that's what I'm going to do. I am going to draw the 4 bonds for each of them. So I'm going to take a look at this carbon. This carbon here already has 1 bond, so I would need another 3. 1, 2, 3, plus the one that is already here, that's 4. What about this carbon here? This carbon here has 2 bonds already, so I just need 2 more. 1 and 2. This carbon has 2 bonds, I need 2 to complete the 4. This one already has 2, all I need 2 more. And this one, this carbon here, already has 1 bond, so I need 3 more. 1, 2, and 3. My next step is always look at my original condensed formula and figure out or imagine that whatever is to the right to that carbon is going to be attached to that carbon. So let's take a look at this carbon. To the right are 3 hydrogens. So these 3 hydrogens are going to be bonded to that carbon. Next to this carbon are 2 hydrogens, so these 2 are going to be bonded to that. The same thing happens here. Here, next to this carbon is oxygen, so this oxygen atom is going to be bonded to that carbon. And here I have 2 different pieces of information. On one hand, I have 2 hydrogens, and they're going to be bonded to that carbon. But I also have an OH, and that OH, since it is to the right of the carbon, must also be attached to that carbon. So, in the last step, I have to locate each of the atoms bonded to that particular carbon that I'm looking at and draw them here. So that's what I'm going to do. This carbon has 3 hydrogens and corresponds to this carbon here. Since I already have 3 spaces, all I need to do is put 1 hydrogen in each space. So 1, 2, 3. That's it. I have them complete. Now, the next one is this carbon here. I need 2 hydrogens and I have 2 spaces, so I'm going to put them here. The same happens for this carbon here. I need 2 hydrogens and I have 2 spaces, so I'm going to put them here. And then this carbon here. Now this carbon is tricky because I only need 1 oxygen attached to it. So I put it here. But the problem is that if I do that, this bond would not be used. So technically speaking, carbon would have 3 bonds. That's violating rule number 1. And also my oxygen atom only has 1 bond, and that's violating my rule number 2 because oxygen must have 2 bonds. So how do I fix that problem? If I realize that this bond here is not really there, But here, that solves the problem, because that way my carbon atom would have 1, 2, 3, 4 bonds, and oxygen would have its 2 bonds. So basically, carbon is double bonded to oxygen. Now, let's take a look at the last carbon here. I have 2 hydrogens and I have 3 spaces available, so I'm going to put them in 2 of those spaces. So what do I have left? I have left an OH. But there's 2 possibilities. I could either put the hydrogen here and the oxygen there, like this, or I could put it this way. Now the problem if I put it this way is that hydrogen would be bonded on 2 sides, on one side to carbon and oxygen on another side. So this can't be an option because hydrogen can only have 1 bond, right? And oxygen must have 2. So the correct way to put it is the other one, in which oxygen is in the middle and hydrogen is outside. That way my oxygen atom has 2 bonds and hydrogen has 1, while my carbon has 4 bonds. So this is the correct structure. So now you have all the tools necessary to translate any condensed formula into structural. Just follow them and apply them whenever you have the opportunity. So stay tuned.